Today we launch into logs, and logs is another branch of math. It's got completely different rules than the other branches of math. As in, when we write an equation, we solve it differently. We have different rules, so this is like a whole different language. But good news is you learned a lot of this last year. If you were in Honors Higher Algebra, you had a whole unit on logs. It was like 8 days long, and then you had a test on it. Now, I know that was a long time ago, but the good news is it'll come back pretty quickly. If you have never had logs before, this is going to go insanely fast. All right, but if you've had them before, this will be probably fast enough so that you'll bring back pretty much what you knew last year. All right, so this is pretty much the review day on logs, and then we get into cooler, newer stuff. All right, to start with, would you please turn your iPads my way? I want to make sure everybody's with me, and that some of you aren't just like checking your Etsy page. All right, thank you. Can't tell what page that is, but is that actually it's a blank page, but okay. All right, so the main thing, be able to go back and forth between log and exponential form. And so let me make sure that you get that. If we get nothing else down, let's get this down. Let's say you had that. Well, how do you solve that? If it had been 5 times x, you would have divided both sides by 5. Well, obviously the answer is logs. Duh, the whole title was logs. Obviously there's a log thing you could do, but there is one more way to solve it. I want to see if anybody can think of it. How do you get the x alone? How do you solve this thing?
You do like a fraction or something, right?
I hope some of you have thought through like, if you can factor it, you should, but there's no factoring. So you should at least thought of it. Maybe you could factor it, because it is my favorite saying. All right, so, it's not that. Do you have a hand up?
I don't remember how you do it, but you put them both in the same base.
I like that idea, yes, except that I purposely chose bases that don't get along. If I had chosen like a 25 right here, then you're right, you could make the bases the same. That'd be a great way to do it. But when they aren't the same, all right, and this just proves that in a room of really smart kids, I have said this, I don't know how many times, but I'm going to keep on saying it. By the end of the year, somebody's going to be like, oh, you could graph both sides and see where they cross, because you could. This is what the graph would show you for this y equals 5 to the x. And this is what the graph would show you with y equals 8. And guess what? They would cross. It's never on anybody's radar, but you're going to have a graphing calculator on a lot of the major tests in your life, and the ACT being one of them. So make sure you use your graphing calculator well, and that's one of the things it can do for you. Is you graph the left side, you graph the right side, and you see where they cross. Do you remember me saying that now that I've just said it? Okay, but see, you'll forget about it at the moment. You'll be like in the middle of a problem, and I'm going to keep saying it because later this year there's going to be a lab, and the only way to solve it, graph both sides, see where they cross. But I won't tell you then. There's going to be another time on a test where you have calculators, and people will be like, I don't know how to factor it. And they're like, all you'd have to do is graph both sides, see where they cross. So anyway, we'll keep saying it long enough. Maybe it'll stick. We'll see. All right, so how could I solve this with logs, though? That is the whole point of today, but it's another good chance to remind you that graph both sides is super powerful. Log base 5 of, who knows what's next? 8 equals x. That is how that's written as a log. Now, why is that any better? X is by itself. Very good. Solve for x. So what is the answer? Well, you'd need a calculator, again. And how do you put this in a calculator? Well, you got 2 choices. Some of you guys are going to have a cool enough operating system that you'll be able to just type in log, and then log base actually is what you're looking for on your calculator, which from my experience, there is a shortcut way that you might never remember, but then there's the key where every single function is there. That I want to keep reminding you about. What's that one key where every function is listed under it? Catalog. And that's right above the 0 key. If you go to catalog and you search under L, you do have to arrow down like 12 times. But the good thing is that's a place you can always go to find things like this. I don't want to just give you this next one, which I will, but then you're going to forget it. Okay? But everybody try this one just because it'll be a quick way to get there. And some of your calculators won't have this ability because it's not a new enough calculator. But if you've gone through this, the zero thing, which is the catalog, and you found log base, you would type it in and make it look like this, log base 5 of 8. And let's just finish this one while we're in there, and I'll show you the shortcut in a second. Is that what you got?
No.
Okay. All right. Do you have it? Didn't get the log base? Anybody got the log base way? What did you get, sir?
1.29202.
1.290, etc. Okay. What is that? That's up here. 1.29. They're saying that 5 to the 1.29 will give you 8. If you type that in, it won't exactly be 8, but it'll be really close. Why won't it be exact? Because you didn't tell me exactly what that number was. That goes on forever. All right, so what's the shortcut way? Everybody try this. Some of your calculators will work, some of you it won't. Math, see the math key? Math alpha.
A.
Yes, and that happens to be the math button. So math alpha math. Math alpha A or math alpha math is another way to think of it. You hit the math button, hit the alpha button, and hit the math button again. You might be surprised. Some of the older calculators can do it. It's if you had 82, there's no way it's going to work.
Where's A?
A is right above the math key. See right above the math key, see the letter?
Did you see the answer? Was that not?
1.29-ish. Is that what you got? All right. So, one more time. 7 to the x is equal to 14. And some people are going to say 2. No. No. 7 squared is not 14. So use logs. And I know some of you are going to think, well, I'll just use my calculator directly. But here's the problem. On the test, you're not going to be using the calculator. I just wanted to show you how you can get the weird decimal answers. On the test, you'd be leaving your answer in the terms of a log. So the answer for this one is log base, what's the base? What here looks like a base? 7. Log base 7, and they never go in order. Try to remember that. They never go in order. Log base 7 of can't be x because he said it never goes in order, so 14. And that is actually superior to what your calculator would say. Know why?
Because it's a calculator.
Because the calculator's got a decimal, and it's going to have to be rounded, and therefore it won't be exact. Everybody thinks of calculators as being super exact. They're actually not. Unless the number comes out to a nice whole number. If the answer comes out to 1.694327948, do you get the calculator can't actually get every digit on its screen? It's going to have to round it, and then you usually round that, and so it's not exact anymore. This is exact. Log base 7 of 14. All right, now what is it though? It's a number, like a decimal, and I can tell you it can't be bigger than 1, like 2, because 7 squared is 49, and that's way bigger than 14. But it can't be just 1, because I know that if I put just a 1 here, 7 to the 1 isn't 14. So it's got to be between 1 and 2, so it's 1 point something. Yes?
Can I ask a off-topic question?
I will pause for just a moment. So, I'm hoping that if I give you a log now, you can go backwards.
Yeah.
Can you make that into an exponent problem? Because the way it is right now, you would be hard-pressed to get the x alone. So then that's the key. If you ever get stuck and you're like, I can't get the x alone, then rewrite it into the other form, and the answer will show itself. Did you say 2? And then you remembered, oh, they don't go in order, so it's not 2 to the x. 2 to the third equals x. And look at that, the x is alone. It's solved. So what is the answer? X equals what? 2 to the third, which is 8. All right. Okay, now, this is where it's going to start going kind of fast because there's a whole lot of little patterns about logs that you need to know. You ready? Log base 3 of 9. Well, that's the same as log base, log base 3 of 3 squared. Can't argue with that. Same thing as 9. And that reminds me that if the bases are the same, my saying goes like this. If the bases are the same, the answer's already there. The reason I say it that way instead of the answer's the exponent is because there are 3 situations in logs where the bases end up being the same, and then the answer will be on the page already. If the bases are the same, the answer's already there. So the answer for this one is 2. If you put this in a calculator, it would say that the answer was 2. So that means wherever this is in a problem, you can replace it with a 2. Sometimes people get confused that, yeah, you can just remove all of that and just put a 2 there because it's the same thing. You can simplify problems a lot then if you know that. All right, so next little thing that goes with that, if we know that that answer is 2, try to put this together in your head. Do you get that the 2 could be moved up to the front? Process that for a moment. Because then what's log base 3 of 3 equal to? 1. Since the exponent on it is a 1, then 2 times 1 is 2. That means that this number can always be moved down into the front if you want to. That is called the power rule. Okay, so what if I had log base 2 of 1/2? I know the answer. Do you know the answer? Hint, you may want to rewrite that 1/2 as a 2, because then the bases would be the same and then you'd know the answer. So this is log base 2 of 2 to the, this makes you remember fraction exponents and negative exponents and negative fraction exponents. So, man, you have to know a lot of little things today. But at the end of the hour, I think you'll be good at it. I really do. As long as you stay with me. 2 to the, who knows it? Negative 1, very good. Because anything to the negative 1 power is the flip of it. All right, so now I need to do a little sidestep and talk about powers, like weird powers like that, because that's going to come up because of the whole fact that we're in logs. And the fact that the power on your base is usually the answer. All right, so we got to be pretty good at fraction exponents, so let's do a few. Who remembers, let's say it's the ACT, to add some context, you're being asked what 27 to the 2/3 power is. Do you remember what 27 to the 2/3 power would be? All right, in case you've forgotten, this is the same as 27 to the 1/3 power, but then squared. Well, what's the bottom part? The 3? That's what root they're taking. That's the 3rd root of 27, which is what?
3.
3. This part's 3. You get seeing that? 'Cause 3 times 3 times 3 makes 27. All right, so if that's 3, then it's 3 squared. So what's the answer?
9.
9. What if I had to put a negative right here?
Where?
Right there in the power. Then what would the answer be? 1/9. Remember, negatives just make it a fraction. All right, let's see if you process that. What is 9 to the negative 1/2 power? Don't say it out loud. Write it on your paper. Turn it my way, and I'll tell you if you're right. 9 to the negative 1/2. Hint, first of all, you're doing the root. Yes, yes, yes. 3 people have it right so far. Yup. 4 people have it right so far. Usually goes like popcorn. Those are the first kernels. Don't be the last kernel.
What?
I'm not the last.
Yes, yes, yes,
I'm the right kernel.
yes.
I'm not the first kernel.
Oh, there it is. Yes,
You guys are burned.
yes, 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 yes. And some of you are that kernel that's just never going to pop and is going to like break somebody's tooth. All right.
I was like, oh gosh, what's the
It's going to be
You are hard.
3. Why 3? It's not 3. I'm not done, but why the 3?
Because 9 to the 1/2.
Because 9 to the 1/2, because that's really the square root of 9. And then what about the negative? That makes the answer
Of fraction.
1/3. Okay. All right. One last one like that. If I had 1/4 and I wanted it to change into a 16, what power would you put it to? If you had a 1/4 and you wanted it to change into a 16, what power, fraction power, hint, hint, would you put it to? Well, it's not really much of a fraction. Yup. 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 Close. Yup. You were thinking the 16 would want to be square rooted, but the 4 wouldn't want to be square rooted. Yup. Yup. Too much glare, sorry.
I know, but I'm not really.
There we go, yes. All right. You should have said just 2. No, 2 is a good way to start though, because that squares it and it makes it 1/16. And then you go, oh, I'm really close. All I got to do is make it flip negative in front. -2. Okay, now why is that so important? Because here's a typical question. Log base 3 of 1/9. And you could be expected to tell what that answer is. Well, hint, if you could write the 1/9 as a 3 to a power, then that'd be easy. Give this one a try. Hint, you're rewriting it as log base 3 of 3 to a power. So I had a student say x equals -2, but I never said what x was. I guess we're going to say that that's x. And therefore the answer is, you're right, -2. Because 3 to the -2 would make 9 except flipped, so 1/9. So really this is like log base 3 of 3 to the -2, and therefore the answer is -2. Okay, how about another one that's even weirder? Log base 4 of the 3rd root of 16. Yuck. If you can write that as 4 to a power, then the answer is just the power. This time, instead of showing me, find a kid who's also done and compare answers with them. All right, I hope you thought log base 4 of, how would I make a 4? If you just start with the 4 and then you start doing stuff to it, like, well, I guess I could square it and that would make it 16. Well, yeah, well, I need a 2 in my power then. And then, oh, and then the root part is the bottom part, so it's just 4 to the 2/3, and therefore the answer is 2/3. Raise your hand if you had that one right. Okay, so some of you guys, these are coming back quicker than for others, but these are important in the context of logs. All right, so let's do a few more things that you have to know about logs. And there's quite a few, and I mentioned this is going to go fast. So here's some more. What's log base 2 of -2? Trick question. The answer does not exist. No solution. Why? Because you can't have negative bases or arguments. Which one's the base? That one's the base. That one's the argument. We could argue about why. And the other answer that isn't here right now is called the exponent. Why is it called the exponent? It doesn't look like an exponent, because if I rewrote it, I'll do that in blue, it'd be 2 to the x equals -2. And think about that. How could you put something to a power that would turn it negative? There is no such a thing. You can't do that. You can put something to a power, you can make it bigger. You can make it smaller, but you can't make it get turned negative. Okay, so there's no way to do that. So you can't have bases that are negative, you can't have bases or arguments that are negative, and you can't have zero for the base or the argument, either one. They can't be 0 and they can't be negatives. I asked last hour and nobody's able to identify the family of numbers that would be. Can't be negative, can't be 0. Some people said whole numbers. No, whole numbers include 0. Natural. That's it. The natural numbers. Why would that ever matter? On a test where they'd say, where x needs to be a natural number, well, 0 might have been the answer, but it can't be because x needs to be a natural number. And anyway, natural numbers are 1, 2, 3, 4, etc. No decimals. So bases and arguments need to be natural numbers. But wait, kind of not, because you can actually have fractions. So not just natural numbers, because you can also have fractions. So really it'd be safest to say that they need to be not integers, but real numbers that are greater than 0. Now the only other thing I would say is a lot of people, this one hurts their head, but you can't have a base of 1. Let me prove it to you. Let's say that that was possible. Then what would the answer be? Well, I'm going to call it x. 1 to the x has to equal 8. Good luck finding a number that would make that happen. You see what I mean? You might think you can make a number grow by putting it to a power, but not the number 1. That's why 1 can't be a base. So they can't be negative, they can't be 0, and you cannot have a base of 1. Now what about the argument? Can that be 1? Yes, it can. Watch. I've got a snappy saying for this one too. Anybody remember this saying from last year? If you won the argument, you get nothing. Very good. Answer is 0. Because 3 to the 0 equals 1. If you won the argument, you get nothing. You put a 1 in the argument spot, you will get 0. Okay. And there's a lot of life situations that I've been into where you end up having this long argument about something stupid. Even if you win the argument, you get nothing because you've just been arguing about what's better, pepperoni or sausage.
Or cheese.
Usually there's somebody who has to say something right there where it's like sausage clearly. But nobody even bit. Okay, fine. All right.
I said or cheese.
I get you. In the real world, if you're the lawyer arguing on the side of the plaintiff and they are suing for a bajillion dollars because you just, your client, the vaping company, somebody has to represent them and try to prove that the poor person that's got some lungs of a 70-year-old, it wasn't because of vaping. Anyway, if you have to argue it, if you do win the argument, you can actually get a lot. There's in the real world. But I've been in many arguments where if you win a dumb argument, then you get nothing. Okay, so I'm going to stick with my dumb little saying, won the argument, you get nothing. How about this one? How would you solve that? Am I in your way? Hint. Who has already moved the 3? Ah, that was smart. A couple people caught on to that. And that goes up here as a power on the argument. I'm not trying to spy on you. I'm just trying to get out of everybody's way and spy on you. Okay. Did you rewrite it then as 2, and remember they never go in order, 2 to the 4th equals x to the 3rd? Huh. Is x alone? No, but it's close. What could you put it to the power of that would get x alone? Power of 1/3. And now the x is alone, and x is equal to 2 to the 4/3. Now that's not a nice number, it's a decimal, but hey, the cool part is x is alone. You solved it for x. Okay, so what other kind of logs do we have to know? So many things. Remember when I said if the bases are the same, then the answer's already there? Are the bases the same on this one? So the answer's already there. What's the answer? 8. Why? Think about it. Log base 2 of 8 would be the same as log base 2 of 8. It has to be an 8. All right. So if the logs are the same, I don't want to say you can just cancel them. It's very tempting to, because it seems like that's true, but there is no, there's no canceling of the logs. You can't just go through and say, cancel, cancel. Well, when things cancel in the real world, it's because they divide and equal 1. I'm not dividing both sides by log base 2, so you're not really canceling the logs. It's not like we're even going to test you on that. I just don't want you to think. Some teachers just cross these off and imply that they cancel. But technically, what's really the case, trying to make you a little smarter, is that that just has to equal that. Doesn't mean that the other thing's canceled. That just has to equal that. All right, same idea. If I say log base 2 of 5, and then I put a base 2 out in front of all of that, now it's not a log anymore. What? It's an exponent problem. And what is the exponent? Log base 2 of 5. Yep. And what is the answer? Good guess, but no. 2 to the power of log base 2 of 5. Oh. All right. I'm going to say this again. When the bases are the same, the answer's already there. What do you think it is? 5. I could prove it, and I will prove it, but just ponder that for a moment. The bases are the same. That's the base in the log. This is the base of the exponent. Okay? And if the bases are the same, the answer's already there. So, I can prove it, though. Watch. If I don't have an x, this is an important thing to know. You can say equals x. And that allows you to rewrite it, because now I got stuff on both sides. And this is going to blow some people's minds. This is not a log, because it's an exponent problem. So I can make it into a log by saying log base, that's the base, and then you never go in order, so then I would jump over here, is equal to, jump back over here, log base 2 of 5, and look at that! We just did that a second ago. So this must equal this. X must be 5. You don't have to prove that, you just have to know that, and it does follow that little pattern of if the bases are the same, the answer's already there. Okay, so that I showed you 3 instances of that, where if the bases were the same, then the answer's already there. All right, so here, there's a lot of this in your homework. Log base 2 of 3 equals 8. Now, is this a true statement or is it not a true statement? This was not a true statement. Just because I write it doesn't mean it's true. You can write 2 plus 2 equals 12. So what would prove that it's not true to somebody who thought it was? 2 to the 8th should equal 3, and it does not. All right. Let's go the other way. Let's say we had 4 to the x equals, well, 16 would be too easy, so 17. What's the answer in log form? The answer as a log. Log base what? Log base 4 of 17 equals x. Now, if you had that put it in the calculator, you could either say log base 4 of 17, or one more thing, and this is called the base change formula. If you have the old kind of calculator that can't do a different base than 10, if your button just says log on it, and that's the only kind of log you can do, which is base 10, then here's how you do it. You go log 17 divided by log, what? 4. Everybody try that on your calculator. I want to make sure that you know how to do it that way, because the people that have a calculator that can't do fancy bases can at least do this. Yes?
Are we gonna have a calculator on the test?
It's a good question. I'm not telling you yet. My gut says actually no, but you'd have to be able to do what you usually do is there'll be like one question, if I remember right, where you would want a calculator, and then we just ask you to tell us exactly what you would type on the calculator if you had one. Because otherwise the calculator would solve so many of the questions on the test that it would make the test kind of useless. Okay, so if you got log 17 divided by log 4, what did you get when you typed in log 17 divided by log 4? It looks like 2.04. Anybody verify 2.04? Okay, good. So 2.04, and I just want to clarify something. That had a base 4, but now it's got a base 10. You might not have even noticed because I just wrote log, but I never wrote what base it was. If we don't say the base, it defaults to 10. So this means this was log base 10. All right, now this is going to freak some people out, but I think it's worth mentioning. ln 17 over ln 4 would have worked also. It would have also given you 2.04. But is ln the exact same thing as log? No, it is not. A regular log without a base is called the common log, and it's got a base, it's just that the base is 10. How about ln? Base of e. So this is really saying log base e of 17 over log base e of 4 will also be 2.04. It's true, you've got an ln button on your calculator and it would work just fine. Because the bigger the base is, the smaller your answer is. Log base e, anybody remember how big a e is? It's actually just a number. 2.7 rounds to 3. That's not bad. Okay, so 2.718. And these answers with the smaller base are actually bigger answers, but when you divide them, they're still going to have the same ratio. So let's say they gave you this log base 9 of 10, and they say that is not base 10, that's base 9. Change this problem to log base 10. Think of it as I just asked you to enter it in an old calculator, because that would put it in base 10, because a calculator would only have a log button, and that's base 10. And you would say log 10 over log 9. And why is that base different? Because this one had a base of 9. This one has bases of 10. And the answer is still the same. And this way you could do it on a calculator. Okay. There's a whole bunch of things about logs. And now this is the part where you need to find the homework. I want to pause for a second while we pull up that page. Okay, so we're in the neighborhood of page 5 in the kids file. And this seems like a ton of questions. And again, I guess it is, but they're super quick. And so you're doing the whole first page. I'll go back and show you how quick. But so for instance, in here, it asks you to write it in the other form. Is this log form? No, I don't see the word log anywhere. So then you make it a log. Log base 5, because that number looks like a base, because it has that exponent. And remember that you never go in order. So the next number is not negative 3. Log base 5 of 1 over 125 equals negative 3. Now I know some of you are like, yeah, it does. That's not the point. These are all true statements. Every one of them is true. The only thing we're doing is rewriting from exponential to log form. Let's do number 5 together. And don't think about how you need to, like, oh my gosh, I got to do the square root and I got to flip it. And That actually would be true. If you square rooted both of them and flipped them, it would be true. But this is about rewriting. Log, what's the base? 4/25 of 5/2 is equal to -1/2. Now there's a negative in this one. Is that legal? Yeah, exponent's going to be negative. The base and the argument, these guys, those cannot be negative, but the exponent can. All right, so you keep switching them back and forth. This is the first one where you have to switch from a log to an exponential. It'll be 5 to the what? Squared is equal to 25. There, that went from a log to an exponential. Or to exponential form, at least. There isn't an x in the exponent, so I'm tempted to not call it exponential form, but that's usually the way we say it. Exponential equations. Like this. All right. I think that keeps it reasonably sized. And that's all I have for you for the video for today. Then the next page, too much of a good thing. We're going to cross off the right-hand side. And the next page, we're going to skip that whole page. We are going to do those tomorrow. It's talking about domain. To really understand domain, I need to take time to graph it and stuff, and I don't have that time right now. So, also want to get your test back to you at the very end here. So let's get back, and I'll show you a little bit how to do the beginning problems